In the last lecture, we have seen the distinction between external and internal performances. In this lecture, we will deepen the external ones, tackling the customer service. Customer service supports two types of processes, marketing and sales. For each of them, there are specific indicators to be measured. Referring to marketing, one of the most common indicators is the product weight. For the sales, the main ones are order cycle time, punctuality, completeness, and flexibility. In this lecture, we will see the product weight and the order cycle time. In next lecture, we will deepen the other indicators. Let's start from the product weight, which represents the number of different items offered to customers. It depends on the number of product families or typologies of models, known as horizontal weight, and to the number of items of each product family and model, known as vertical weight or depth. It is valuable for the customer because the higher the weight, the higher the possibility to meet his specific needs. The product depth depends on the complexity of the product hierarchy and so on the number of models, the number of products, the number of different versions per model, the number of different versions per product, and the number of side models. Let's make an example. If we consider the Coca-Cola company, first, it offers many different products like Fanta, Coke or Sprite. Second, if we focus on Coke, it has many variants. There are, for example, the Light Coke, the Classic or the Zero one. Third, we may find the Classic Coke in a can or in a bottle of different dimensions and of different materials. For example, we can have a can of Classic Coke, which is a single item. Moreover, a single piece, as a Classic Coke can, may correspond to different SKUs. It can be sold as a single piece, in pair, or in a box containing different cans. Let's switch now to those indicators related to the sales, starting from the order cycle time. It is defined as a time window between the moment the order is issued and the time in which the order is delivered. It depends on the times to conduct all the activities in different phases of the order cycle and the probability to avoid stockout. The order delivery cycle time is valuable for the customer because the lower the order cycle time, the lower the risks associated to the supply, and as a consequence, the lower the safety stocks. If all the ordered items are available in the stock, the order cycle time is the sum of the times to carry out the following activities: order processing, order preparation, and shipping. In case of an availability, it is instead necessary to wait for the replenishment from other warehouses, production plants, or suppliers. So the replenishment time has to be added to the previous ones. We may identify the percentage of orders, or lines, delivered with a certain order cycle time. Referring to the orders, this percentage is calculated as the number of orders delivered within that specific cycle time and the total number of delivered orders. Referring to the example shown in the picture, the 80% of orders are delivered within 7 days. 95% of orders are instead delivered within 10 days. The same approach can be applied to order lines. When an order is issued, it can be completely fulfilled or there could be a stockout. A stockout occurs when some of the ordered items are not available on hand for the delivery. It is linked to the number and the typology of items on stock and to the quantity available for each item. It is directly perceivable by the customer when the cycle time is zero, as for example in a supermarket. It also influences the order cycle time. The higher the probability to avoid the stockout, the lower the value of the cycle time. We may refer to the probability to avoid the stockout both to orders and to order lines. The probability to fulfill an order, or the probability to avoid a stockout, is calculated as the ratio between the number of orders that can be fulfilled straight from the inventories on hand, and the total number of orders received and potential. Similarly, the probability to fulfill an order line is given by the ratio between the number of lines that can be fulfilled straight from the inventory on hand and the total number of lines received and potential. Let's see an example in order to better understand this concept. There are 5 orders. For each order, there is a list of all the required lines and quantities. Items A, B, D, E are available and they are enough for fulfilling all the 5 orders, but there is only a limited quantity of C. Though orders 2, 3, and 4 can be completely fulfilled, while orders 1 and 5 cannot. The probability to fulfill an order is calculated as 3, the number of orders that can be fulfilled, divided by 5, the total number of orders, thus resulting in 60%. The probability to fulfill an order line is instead computed as 16, the number of lines that can be fulfilled, divided by 18, the total number of order lines, resulting in 89%. In this lecture, we have seen the most common marketing and sales indicators, and we have deepened the product width and the order cycle time.